In this unit, we're going to use Redis to build a leaderboard. Leaderboards are often used to show or retrieve the rankings of players in a game or competition. In this case, we're operating as a kind of electrical utility, so we'd like to have the ability to see the best and worst performing solar sites. The way we do that is to monitor solar site capacity. Every time we receive a meter reading, we're going to record the capacity of each site. We'll use this information to build a real-time capacity leaderboard. The Redis-based leaderboard we're building will power the capacity charts you see here. This one shows the sites with the greatest capacity. And if we scroll down, you can see the sites that have the least capacity. We'll be using sorted sets to implement our leaderboard. Let's call this sorted set the capacity ranking sorted set. Here's how this sorted set will look. The scores will contain the current capacity of the site, while the site members will contain the site IDs. Each time we receive a meter reading, that is, every minute, we'll update the sorted set. If you open up Redis Solar/DAO/Redis/capacityreport.py, you can see the update method that performs this update. First we grab the key. Then we calculate the current capacity, which is the watt-hours generated minus the watt-hours used. We then run the zadd command, passing in the key, the site's ID, and the current capacity. Now we also need a method to get the top n and bottom n values from the sorted set and return them in the form of a report. To accomplish this, we use the zrange family of commands. Zrange returns set members with scores from lowest to highest, while zrevrange returns set members with scores from highest to lowest. Let's see how this plays out in the code. Have a look at the getReport method, which returns a report object containing the top n and bottom n values from the sorted set. Here's the part of the method that interacts with Redis. As you can see, we first create a pipeline. Then we get the n sites with the least capacity by calling zrange, passing in the key and the range. To get the n sites with the greatest capacity, we call zrevrange in a similar fashion. Notice that we're using the withScores argument in both method calls. This argument will return the score, which here is the site capacity with each call. Finally, we call execute to send the pipelined commands across the network and to the Redis server. The rest of this method does some basic data transformation, which we won't go over here. These two methods get us most of what we need for a leaderboard. Of course, one global leaderboard may not always be enough. In addition to a global leaderboard for all solar sites, we might want one per city, or even one per region. And it's relatively easy to accomplish this with some creative key naming. We might also want to give solar site owners the ability to see their ranking. This is in fact a feature provided by Redis sorted sets, and in the next challenge you'll get the chance to implement it. Two more notes on sorted set-based leaderboards before we move on. First, remember that the zrange family of commands has performance of O log n plus m, where m is the number of elements returned. In our use case, we expect a relatively small sorted set cardinality, so there's no real performance concern for this use case. But if your sorted sets or leaderboards contain millions of unique elements, you may want to exercise some caution when pulling back large ranges. Second, know that there are several commands that can help you keep your sorted sets from growing too large. The zrem family of commands, including zrem range by rank, is worth looking at if you need to keep your sorted sets trimmed for performance purposes. So in this unit, we saw how to create leaderboards in Redis using sorted sets. These leaderboards are used primarily for powering our max and min capacity charts, but we'll also use them a bit later to add capacity criteria to our geo searches.